Hi, welcome back. This is lesson 93 and it's all about dot plots. We're going to show you how to actually draw dot plots in this lesson, and by the end you'll be able to successfully draw and label a dot plot to represent a data set. We'll construct frequency tables to organize our data, and we'll determine the shape of the data using terms like skewed or symmetric. And finally, as we're describing data later in this unit, we'll talk about, well, where do we see peaks, gaps, and clusters in the data, and what does it mean in the context of the problem? Let's explore these dot plots. Here's our first question. A random sample of teens aged 12 to 14 were asked, on average, how many texts do you send per day? The results are represented below. So this is our data set, and we're going to place it on the dot plot. Okay, so all I'm going to do is I'm going to take each number and place it on a dot plot. You could do this one at a time and it can take time, or what I also like to do is I like to just look at our data, and sometimes I like to organize it. I like things organized. So I can see 3 people said 20, 1 person said 30, 3 people said 50, 1 said 90, and 2 said 100. So the reason I like this is because imagine if I'm sitting there going, my brain might going, oh, 10, 10, oh, 10, 10, and looking one at a time versus I see 4 people said 10. So I'm reducing the back and forth. 3 people said 20. 1 said 30. 3 said 50. 1 said 90. And 2 people said 100. Okay. Now I will say that it was easy for me to do this because my data was already organized. It was already ordered from least to greatest. That will not always happen. However, if you get really good at using spreadsheets and putting your data, you can just actually put things in order really easily. You can just set a button and it will order it for you. So I love spreadsheets. Here we go. So we have this. Now let's look at our first question. How many teens were surveyed and how do we know? Well, all I have to do is count up my data set. I can either count from here or count from here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And how do I know? There were 15 responses in the data set. That's it. So again, you could have also counted it here and just gone 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Either way, you can just look at your data and do a count. Let's look at the second part. Describe the shape of the graph. How can you determine the shape of the data? Okay. When I'm looking for the shape, I'm looking for clusters. I'm looking for, is there an increase, a decrease? And so what I notice is we have a lot of data around here. So I starts out low with 10, and then I get a little spike in my data set. It goes down, spikes up again at 50. Then there's nothing. It's a gap. And then it spikes up again. So it's low, it spikes, decreases, gap, spikes again, gap, spikes again. So there are 3 clusters of data. Out of my 15, you can notice that most of my data is under 60 text. Matter of fact, let's look at my first cluster here. It's 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 out of 15 responded 30 or less. A spike at 50 a cluster of 90 to 100. And you can see where I have no data. So there's a gap here and a gap here. I don't have a lot of space, but you can see how I'm looking at my clusters. I can see the peaks. So that's my highest data was at 10. So I'm going to say that as well. The peak was at 40. 4 out of 15 responses. Okay, so let's hit pause and jot this down, but you can see there are tons of different ways I can describe our data set. All right, let's go to the next one. Miss Ortega recorded the number of siblings each student in her class has. Her data are shown on the line plot below. Okay, so you can just see X's just same way as little dots. What is the total number of students in Miss Ortega's class that have 2 or fewer? So I'm looking on my number line for anything that is 2 or less. And looking here, we're separating this, and this represents 2 or less siblings, sibs. And I can just count this up now. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 students have 2 or less siblings. Let's try and also identify a distractor here. What would have been a distractor? Well, I can see why would a student have chosen 20? So 12, 13, 14, 15, 16, 17, 18, 19. So maybe someone just looked at all of it and said 19 is close to 20. Possible. Why might someone have said 5? Well, they could have said 5 if they said 1 is fewer than 2 and there are 5 students here. And they probably could have done the same thing for 3 if they would have picked another lower number, another data value that had less than 2 siblings. So those are the possibilities. But that's it, Math Marbles. I can just draw the line and look for the information I wanted. The key here was 2 or less, meaning I had to include 2 in our data set. We were looking for all numbers that were less than or equal to 2. All right, hit pause, jot this down. And I will see you in the next lesson, Math Marbles. Be well.